You know, when you really sit down and think about it, there's something almost magical, almost dreamlike about the story of Albert Einstein. And I'm not talking about the stuff they drilled into your head in high school, not the equations on blackboards or the test questions about E=mc². No, I'm talking about the real story. The messy, complicated, beautifully human story of a guy who literally couldn't get anyone to hire him as a teacher, and somehow, someway, ended up completely changing how we understand literally everything about reality itself. So let's start at the very beginning. Take a moment and picture southern Germany. It's 1879, March 14th to be exact. Spring is just starting to arrive. In this city called Ulm, tucked away in what was then the sprawling German Empire, a baby boy came into the world. Just another birth, right? Just another family welcoming a child. But this particular baby, this little boy, would one day grow up to make us completely rethink space, time, matter, energy, and reality itself. But on that day in March, he was just another kid, just another infant crying in the night, needing to be fed, needing to be held. His parents, Hermann and Pauline Einstein, had absolutely no idea what was coming. How could they? They were just ordinary people trying to make their way in the world. Now, Hermann Einstein was actually pretty interesting in his own right. Really smart guy, genuinely talented, especially when it came to mathematics. He'd spent time studying in Stuttgart, which was the capital of Württemberg, and he showed real, genuine promise. His teachers thought he could go far. But here's the thing about life back in the 1870s, and this is something we sometimes forget. If you didn't have money, if your family wasn't wealthy, then talent alone only got you so far. It didn't matter how brilliant you were. Hermann's family wasn't wealthy, they were working people. So despite all his mathematical ability, despite all that potential, he had to drop out of school. Just had to leave. And where did he end up? Working in his cousin's feather bed shop in Ulm. Yeah, feather beds, can you even imagine? All that mathematical talent, all that ability with numbers and equations, and he's measuring and selling feather beds to people who wander into the shop. Pauline, Albert's mother, came from a somewhat different background. Her family, the Kochs, were German Jews, and they'd actually done pretty well for themselves over the years as merchants and traders. They had connections, they understood business, they knew how to navigate the commercial world of Württemberg. She and Hermann got married in 1876, and Albert was their first child, their firstborn. Then 2 years later, in 1881, they had a daughter. They named her Marja, though some people called her Maria, depending on who you were talking to and where you were from. She'd become pretty important in Albert's life as they grew up together. Now, when Albert was still just a tiny baby, barely old enough to remember anything that was happening around him, his father Hermann made a decision that would completely set the whole Einstein family on an entirely new path. His brother Jakob, who was always looking for opportunities, convinced him that they should get into the electrical engineering business together. And you have to understand, this was the 1880s, right? This was a time when electricity was just starting to become a real thing, a practical thing that was about to change absolutely everything about how people lived. Cities were starting to light up at night for the first time in human history. Streets that had been dark for thousands of years were suddenly glowing. Machines were beginning to run on electrical power instead of steam or manual labor. It was revolutionary. Honestly, it was like the internet boom of the 19th century. If you could get in on the ground floor of electrification, you could make a fortune. So Hermann and Jakob, they packed everything up and moved the family to Munich. Much bigger city, way more opportunities, more potential customers, more potential contracts. They called their new company Einstein & Co., and for a while there, things actually looked pretty promising. They were optimistic. Hermann and Jakob really believed they were going to ride this massive wave of electrification that was sweeping across Europe and America. Young Albert, meanwhile, got enrolled in a Catholic elementary school there in Munich. Yeah, I know, a Jewish kid in a Catholic school. Seems odd today, but that was just how things worked sometimes back then. The schools were often religiously affiliated, but they'd accept students from different backgrounds. Later on in 1887, when Albert was 8 years old, he got transferred to the Luitpold Gymnasium. That's basically what they called a prep school in Germany, if you're wondering about the terminology. And he stayed there, grinding through his studies, until he was 15 years old. But here's where the story starts to get really interesting, where things take a turn. Because in 1894, everything just completely fell apart for the Einstein family business. You see, Hermann and Jakob had been working for years, building up their company, making connections, and they'd been competing for this absolutely massive contract to electrify the entire city of Munich. Can you even imagine what landing that contract would have meant? It would have set them up for life. Financial security, prestige, everything. But they didn't get it. They lost out to a competitor. Just like that, after years of work, years of sacrifice and hopping and planning, it was gone. Someone else got the contract. So what did they do? Well, they left Munich. They just packed up the whole operation, all their equipment, all their plans, and they headed south to Italy. First, they went to Milan, that beautiful city in northern Italy, and then they moved to Pavia, which is nearby. Fresh start, new opportunities, maybe things would be better there. But here's the thing, and this is important. They left Albert behind in Munich. Yeah, they actually left their teenage son behind. The plan was that he was supposed to finish his studies at the gymnasium, keep his head down, don't make trouble, study hard, graduate, and make something of himself. Get that diploma that could open doors. But Albert, oh man, Albert hated it there. He absolutely despised it. And you really have to understand what education was like back in those days to appreciate why. It wasn't about thinking or questioning or exploring ideas. It was all rote learning, pure memorization. You'd sit there and the teacher would lecture, and you were supposed to just absorb it and repeat it back exactly as you'd heard it. No creativity, no questioning, no asking, but why does it work that way? Just repeat what the teacher says and don't ask why. Don't challenge anything. Don't think for yourself. For a mind like Albert's, for someone who was naturally curious and questioning and wanted to understand the deeper reasons behind things, it must have been absolute torture, like being in a prison for his mind. So after a few months of this, after enduring this stifling educational environment, he basically convinced everyone involved, his parents back in Italy, the school authorities in Munich, that he needed to leave. He made his case and he won, and he did leave, just packed up his things and joined his family in Italy. And I kind of love that about him, 15 years old and already following his own path, already refusing to just go along with what everyone expected of him, already thinking for himself. Now, while all this drama was happening with the family business and the moves between cities and countries, something absolutely remarkable was going on with Albert's brain, with his intellectual development. This kid, this teenager, was teaching himself advanced mathematics. We're not talking about basic arithmetic here. In the summer of 1891, when he was just 12 years old, barely into his teens, he taught himself algebra. And not just the basic algebra you might learn in a high school class today. We're talking about advanced algebra, complex equations, the kind of stuff that would challenge much older students. And he was doing advanced geometry too. Euclidean geometry, specifically. That's the geometry that the ancient Greeks figured out thousands of years ago, named after Euclid. Beautiful, logical, elegant mathematics that describes space and shapes and relationships. The family, recognizing that Albert needed guidance, hired this tutor named Max Talmud. The guy was in training to become an optometrist, someone who examines eyes and prescribes glasses, but he knew his math and science pretty well. He was educated, capable, so the Einsteins brought him in to teach young Albert, to help guide his studies and push him further. And here's what's absolutely wild about this. Within just a few months, Albert had completely surpassed him. The student had become the teacher. Talmud would show up for their sessions with new concepts, new mathematical ideas he wanted to introduce, and Albert would just absorb them like a sponge. He'd understand them almost immediately, and then he'd push beyond them, asking questions that Talmud himself hadn't even considered. And it wasn't just math and science either. Albert had this incredibly broad intellectual curiosity. He was reading philosophy. Not simple philosophy, not easy popular books, but heavy, dense, challenging philosophy. We're talking about Immanuel Kant here. Have you ever tried reading Kant? His most famous work, The Critique of Pure Reason, is honestly one of the densest, most challenging philosophical texts ever written in any language. It was first published way back in 1781, and even today, even in our modern era, philosophy professors with decades of experience need multiple careful readings to really grasp what Kant is saying. This book dives incredibly deep into metaphysics, which is the study of the nature of reality itself. It explores epistemology, which is how we know what we know. It questions everything we take for granted about existence and knowledge and truth. Albert Einstein read it when he was 14 years old. A 14-year-old boy, and he not only read it, but he understood it. He grasped the concepts. His tutor Talmud was absolutely blown away, completely amazed. He couldn't believe what he was witnessing. So clearly, obviously, this kid had something genuinely special going on upstairs, something unusual in his brain, in his way of thinking. His teachers knew it, his parents knew it, Max Talmud certainly knew it. That's why shortly after Albert turned 16 and had settled with his family in Pavia, they made the decision to send him to take the entrance examinations for the Swiss Federal Polytechnic School in Zurich, Switzerland. This was a serious institution, understand, one of the best schools in all of Europe for science, mathematics, and engineering, top-tier education. If you could get in there, you were set. Albert did well on the technical parts of the exam, really well actually. He clearly had the intellectual horsepower, the mathematical ability, but they didn't accept him, not that year. The problem was he was too young, just 16, and honestly, he probably hadn't gone through the traditional, formal schooling process that they typically expected from their applicants. He was this odd case, this unusual applicant who taught himself so much but didn't fit the normal mold. So he spent the next year preparing to take something called the Swiss Matura. That's basically an equivalency examination for people who didn't go through the Swiss school system in the traditional way, but wanted to prove they had acquired all the necessary knowledge and could meet the standards. It was his way of showing he belonged. Oh, and there's another detail here that really matters, that tells you something about who Albert was as a person. In 1896, before he even took that equivalency exam, Albert made a dramatic choice. He renounced his German citizenship, just voluntarily gave it up, walked away from it. Why would he do that? Because Germany had mandatory military service. Every young man was required to serve time in the military, and Albert wanted absolutely no part of that. He was a pacifist, deeply opposed to violence and militarism, through and through from a very young age. He couldn't stomach the idea of being trained to fight, to potentially kill other human beings. So for a while there, he was completely stateless. No country at all, no citizenship anywhere, just a young man floating between nations. And there's something kind of poetic about that, kind of fitting, in a way, for someone who would eventually end up thinking far beyond national boundaries, someone whose ideas would belong to all of humanity. Autumn of 1896, at 17 years old, Albert finally entered the Swiss Federal Polytechnic School in Zurich as this stateless young man. And for the next 4 years, 4 important formative years, he studied physics and mathematics intensively. The two subjects, the two fields that he'd been naturally drawn to, almost magnetically drawn to since he was a small child. He graduated with a diploma in 1900, at the turn of the new century. Those years in Zurich, those 4 years of intensive study, that's really when Einstein started becoming Einstein, if that makes sense. That's when the scattered threads of his brilliance started coming together into something coherent. His research interests began to take real, concrete shape in his mind. He was thinking deeply about quantum mechanics, which is the science of really, really tiny things of the subatomic world. Questions like, how do you actually measure the size of something as small as a molecule? What are the fundamental properties of atoms? How do they behave? This stuff was absolutely cutting edge at the time, the frontier of physics. And he was obsessed, genuinely obsessed with light. How does light move through space? What is light made of, fundamentally? What is its nature? Most scientists back then, the prevailing view in the physics community was that light traveled in waves, like ripples spreading across a pond when you drop a stone in, just waves of energy moving through space. But Einstein wasn't so sure about that. He had this nagging feeling, this intuition, that there was something more complex going on, something deeper, something that people were missing, some piece of the puzzle that hadn't been found yet. These questions, these deep puzzles about the nature of reality, would form the absolute foundation of his doctoral thesis, which he worked on part-time throughout the early 1900s while doing other things to support himself. He finally finished it in 1905. The title was A New Determination of Molecular Dimensions. Not the catchiest, most exciting title in the world, I'll fully admit, kind of dry and technical, but the actual work inside, the research and the conclusions was absolutely brilliant, groundbreaking stuff. Now there's someone else we really need to talk about here, someone important in Einstein's life during this period. Her name was Milva Maric. She was a Serbian woman, a mathematician and physicist in her own right, and she was one of only 2 female students at the entire Polytechnic school when Einstein was there. Just 2 women in the whole institution. That fact alone tells you something profound about her determination and her ability. This was the 1890s, remember. Women in science were incredibly rare. The barriers they faced were just enormous, almost insurmountable. The prejudice, the assumptions that women couldn't handle advanced mathematics or rigorous scientific thinking, the lack of opportunities, the social pressure to stay home and focus on domestic life instead. It was incredibly difficult. Malva and Albert started a relationship during their time at the Polytechnic. They fell in love, basically, as young people do. They connected intellectually and emotionally, and it's pretty clear now, based on letters and research that's been done by historians, that Malva contributed to Albert's research in significant ways. But how much? That's still actively debated by scholars. Some historians think she was absolutely instrumental in some of his most important discoveries, that she deserves more credit than history has given her. Others think her role was more supportive, more about being a sounding board and a collaborator rather than originating the key insights herself. The truth is probably somewhere in between those 2 extremes, and we'll likely never know exactly what happened because the historical records are incomplete. Some letters were lost, some were destroyed, some details were never written down at all. What we do know for certain is that in the summer of 1901, Malva discovered she was pregnant. And here's the thing, they weren't married yet, not even engaged officially. And in 1901, in European society at that time, having a child out of wedlock was considered a huge scandal, a massive social disgrace. It could destroy reputations, wreck careers, tear families apart. So Malva went back to her native Serbia to have the baby in secret, away from the prying eyes and wagging tongues of Swiss society. They had a girl, a daughter, and in their private letters to each other they called her Liso. And here's where the story gets really sad, really tragic. We don't actually know what happened to Liso after she was born. The historical record goes dark. Some sources and historians believe she died of scarlet fever, which was a deadly disease back then, in 1903 when she was still a toddler. Others think she was quietly given up for adoption in Serbia, handed over to another family to raise so Albert and Malva could move on with their lives and careers without the scandal following them. It's one of those heartbreaking mysteries that probably won't ever be completely solved. The truth is lost to time, though it seems more likely, based on what evidence we have, that she died rather than being adopted, because by January 1903, Albert and Malva had gotten married. If she'd been alive and in an adoptive home, you'd think there might be more records, more traces. After they married, they went on to have 2 more children over the following years. Hans Albert was born in 1904, and Eduard came along in 1910. Both boys, both sons who would have complicated relationships with their famous father as the years went by. So here's where we are in the story. It's the early 1900s. Einstein has his diploma in hand from a prestigious institution. He's clearly brilliant, obviously talented. He's got these groundbreaking ideas swirling around in his head, questions about the nature of light and atoms and energy that are going to revolutionize physics. You'd think universities would be lining up to hire him, right? You'd think they'd be competing to bring this young genius onto their faculty, to have him teaching their students and conducting research under their banner. Wrong, completely wrong. Albert spent the next year and a half after graduation, 18 long months, trying desperately to get a teaching position somewhere, anywhere, any teaching position at all. A junior lectureship at a small university, a research assistant role, teaching assistant, anything that would let him continue working in physics and mathematics, and he couldn't land a single one. Not one institution would hire him. Can you even imagine how frustrating that must have been? The guy who would go on to completely revolutionize our understanding of physics, who would become the most famous scientist in the world, couldn't get anyone to give him a job teaching it. Rejection after rejection after rejection. But in 1901, at least one good thing happened. He was granted Swiss citizenship, which helped stabilize his legal status. He finally had a country again, a passport, official recognition. And through a family friend, a guy named Max Grossmann who had gone to the Polytechnic school with Einstein and knew his abilities firsthand, Einstein finally got a valuable connection, a way in. Grossmann's father, using his own connections and influence, helped Albert land a job at the Swiss Patent Office in Bern, which was the capital city of Switzerland. Not a teaching position, not research at a university, but it was employment, it was income, it was something. The official job title was Patent Assistant Examiner. Basically, what that meant in practical terms was that people would come into the office with inventions, gadgets, devices, machines they'd created, and Einstein's job, his daily responsibility, was to evaluate them carefully and objectively. Did they actually work as claimed? Were they original, or were they just copying something that already existed? Should the inventor receive credit and legal protection for their idea so they could benefit from it financially? A lot of the stuff he reviewed and examined involved electrical systems, circuits, motors, and mechanical devices, gears and levers and springs and mechanisms. And here's the interesting thing that some people don't realize. Some historians and biographers think this job at the patent office actually helped Einstein's research in physics. It might seem like a distraction, like he was wasting his time on other people's inventions when he should have been working on his own theories. But he was seeing all these different creative approaches to solving problems with electricity and mechanics every single day. Different ways of thinking about energy transfer, about motion, about forces. It might have influenced, maybe even shaped, how he thought about fundamental physics questions, ideas cross-pollinating in unexpected ways. So there's Einstein, the complete picture now, working at the patent office during the day, examining inventions and filling out paperwork, supporting his young family, being a husband and father, dealing with all the ordinary responsibilities of adult life, and finishing his doctoral thesis on the side, working late into the night by lamplight after his wife and children had gone to bed, stealing hours whenever he could. And then came 1905. 1905. Just let that year sink in for a moment. That's the year when everything changed, when everything shifted, when the world tilted on its axis. The year that Einstein went from being essentially a nobody in the scientific community, just an anonymous patent clerk who happened to have a PhD, to becoming one of the most important scientists in all of Europe, one of the most revolutionary thinkers in human history. Historians and biographers call it his annus mirabilis. That's Latin, meaning miracle year or year of wonders. And honestly, truly, it's a completely fitting name for what happened, because what Einstein accomplished in that one single year almost defies belief. What happened was this, and it's extraordinary. Einstein published 4 papers, 4 separate independent research papers, all of them in the same prestigious journal, Annalen der Physik, which means Annals of Physics in German. This was one of the absolute top physics journals in the entire world, published in Germany continuously since 1799. Getting 1 paper published there was an achievement. Getting 4 was unheard of. And each of these 4 papers wasn't just good or solid or competent. Each one was revolutionary, paradigm shifting. Each one individually would have been enough to make Einstein's career, to make him famous in the scientific community, to secure his legacy. Let me walk you through them slowly, one by one, because they're genuinely worth understanding. They're worth sitting with for a moment. The first paper came out on June 9, 1905, early in the summer. The title was On a Heuristic Viewpoint Concerning the Production and Transformation of Light. Try saying that 3 times fast. Quite a mouthful of technical language. What this paper did, what its fundamental achievement was to explain something that had puzzled physicists for years, something called the photoelectric effect. Now here's what that actually means in simpler terms. Sometimes under certain conditions, when light hits a material, any kind of material, electrons are released from that material. They just pop out. Those electrons that get released during such a process are called photoelectrons. It's a weird phenomenon, right? Before Einstein came along with this paper, nobody could really explain satisfactorily why this happened. What was the mechanism? What was going on at the fundamental level? The prevailing theory, what almost everyone believed, was that light was purely a wave, flowing like water, spreading like ripples. Just waves of energy moving through space, nothing more. But Einstein showed, through careful mathematical reasoning and logical deduction, that light doesn't just behave like a wave. It also behaves like it's made of particles, like little packets or bundles. He called them energy quanta, little discrete chunks of energy, like bullets or pellets, traveling through space. This was huge, this was revolutionary. It explained so much about how light and electrons interact with each other, how energy gets transferred between them. It laid crucial groundwork for the entire field of quantum mechanics that would develop over the following decades. And years later, decades later actually, this specific discovery, this particular paper on the photoelectric effect, would be the one cited when Einstein won the Nobel Prize in Physics. Though interestingly, it took until the mid-1920s, almost 20 years after publication, for physicists to fully accept Einstein's explanation and understand that he'd been right all along. Science moves slowly sometimes. Revolutionary ideas take time to be accepted. Then just 6 weeks later, on July 18th, barely any time at all in the world of academic publishing, the second paper was published. This one was called On the Motion of Small Particles Suspended in a Stationary Liquid, as required by the molecular kinetic theory of heat. Another absolute mouthful of technical terminology. This paper was fundamentally about atoms, about whether they actually existed. Now, scientists and philosophers had suspected for a long time that atoms might exist, that matter might be made of tiny fundamental units. In the 1800s, throughout the 19th century, chemists had noticed something interesting. Substances tended to combine together in specific, predictable ratios in definite proportions. 2 parts hydrogen, 1 part oxygen makes water, for example. Always those ratios. This suggested pretty strongly that they were made of some fundamental unit, some smallest building block that couldn't be divided further. Ancient Greek philosophers, brilliant thinkers 2,500 years ago, had even theorized about atoms philosophically. They called them atomos, which literally means indivisible or uncuttable in ancient Greek, the smallest possible thing. But here's the problem. Nobody had actually proven that atoms existed. It was still theoretical, still hypothetical. Nobody had measured them or detected them directly. There was no hard experimental proof. Einstein's paper showed, through elegant mathematics, how you could use something called Brownian motion to prove atoms were real and even to measure them. Brownian motion is this phenomenon where you suspend tiny particles, like grains of pollen from flowers, in water. And you look at them under a microscope, and they jiggle around randomly. They're constantly moving in this erratic, zigzag pattern. Einstein showed that this jiggling, this random motion, was being caused by atoms in the water, invisible atoms, bumping into the pollen grains from all sides. Like being in a crowd of people you can't see, getting jostled from every direction. A few years later, a French physicist named Jean Perrin conducted careful experiments that confirmed Einstein's mathematical predictions experimentally. He actually measured what Einstein had predicted. And just like that, just like flipping a switch, atomic theory became accepted science across the entire scientific community. The debate was over. Everything is made of atoms. They're real. Einstein helped prove it decisively. 2 months after that second paper, on September 26th, deep into autumn, the third paper was published. This one was called On the Electrodynamics of Moving Bodies. Much shorter title, but arguably the most important paper of all. This is the big one. This is special relativity. This is what would eventually make Einstein a household name. There was this deep problem in physics at the time, a puzzle that was troubling the best minds in the field. A brilliant Scottish scientist and mathematician named James Clerk Maxwell had come up with a set of equations about electricity and magnetism way back in the 1860s, 40 years earlier. These were brilliant, beautiful equations that described how electromagnetic fields work, how they propagate through space. But Maxwell's equations created a conceptual puzzle, a theoretical problem. How should we understand what happens to these equations? How should we think about physics? When things are moving close to the speed of light, everything seemed to break down. The math didn't quite work the way it should. Einstein's answer, his solution, was special relativity. And the basic, fundamental idea is actually simple, even though the mathematics gets complicated. The speed of light is constant. It's always the same for everyone, no matter how fast you're moving yourself or how fast the light source is moving. Light always travels at the same speed, roughly 186,000 miles per second. This was totally, radically different from what Isaac Newton had said over 200 years earlier. Newton, the giant of physics, had thought that the speed of light could change depending on your perspective, depending on whether you were moving toward the light source or away from it. like how a baseball seems to come at you faster if you're running toward the pitcher. But Einstein realized that Newton had been wrong about this, that there was something deeper going on. And he realized the truth in a moment of sudden insight while riding a streetcar, a tram, in Bern during the early summer of 1905. He was just riding along, probably tired from work, looking out the window at the city passing by. He was looking at the clock tower in the city center, this landmark that everyone used to tell the time. And he had this thought, this incredible imaginative leap. What if the streetcar he was sitting in suddenly started moving at the speed of light, at 186,000 miles per second? What would happen? The clock on the tower would appear to stop, to freeze. The hands would stop moving. Why? Because the light from the clock face, the light that carries the information about where the hands are pointing, wouldn't be reaching him anymore, or would be reaching him in this weird frozen state. But the clock inside the streetcar on the wall of the tram car would keep ticking normally, second by second, because both Einstein and that clock were traveling at the same velocity together. So time itself is relative. It's not absolute, not the same for everyone everywhere like we intuitively think. It depends on how fast you're moving through space. Speed affects time. If you move faster, time moves slower for you compared to someone who's stationary. That's special relativity, the core insight. Mind-blowing, right? Even today, over a century later, it's hard to fully wrap your head around. And then November 21st, late in the year, the fourth and final paper of this extraordinary year. Does the inertia of a body depend upon its energy context? You might not recognize that particular title. It's obscure, technical, but you definitely, absolutely know the equation that came from this paper. Everyone knows it, even people who never studied physics. E equals mc squared. Energy equals mass times the speed of light squared. This tiny, elegant equation, just 3 symbols and a number, changed everything about how we understand reality. What it means, the deep implication, is that mass and energy are the same thing, just in different forms. They're interchangeable, convertible back and forth. A tiny amount of mass, a tiny amount of matter, contains an absolutely enormous amount of energy trapped inside it, bound up in its structure. Like the nucleus of a single atom, something so small you need an electron microscope to even see it, has enough energy locked inside it to power an entire city for days if you could somehow release it all at once. That's what Einstein showed with this equation, that matter itself is frozen energy, concentrated energy in physical form. Later, decades later, this equation would lead directly to nuclear power plants that generate electricity for millions of people. And unfortunately, tragically, it also led to nuclear weapons, to atomic bombs. But in 1905, when Einstein first published it, it was just pure science, pure mathematics, pure understanding of how the fundamental fabric of the universe works. Can you even imagine, can you even conceive of publishing 4 papers like that in one single year? Papers that would each individually reshape entire fields of physics. Any one of them would be a career-defining achievement, the thing you'd be remembered for. Einstein published all 4 of them, in 1 year, at 26 years old, while working full-time at a patent office, while being a husband and father, while living a completely ordinary life in most respects. It's almost superhuman when you think about it, almost impossible to comprehend. Once word slowly got out about these papers, once they started circulating through the international scientific community, and people started reading them and understanding the implications, Einstein's life changed dramatically and quickly. By 1908, just 3 years later, he had secured a teaching position at the University of Bern. Finally, after all those rejections, he was teaching. He was able to leave his position at the patent office behind. The next year, in 1909, he got appointed to a brand new chair, a professorship of theoretical physics that had been specially created for him at the University of Zurich, his old alma mater. They created the position specifically because they wanted him. They recognized his genius. And he didn't stop working. He kept developing his ideas from 1905, refining them, testing them, pushing them further and deeper. And he started developing something new, something even more ambitious, the theory of general relativity. This would take special relativity, which was already revolutionary, even further into realms that seemed almost like science fiction. But that's a whole other chapter of the story, and we need to follow it because what comes next is just as remarkable. In 1911, Einstein made another move. After spending over 15 years in Switzerland, a place that had become like a second home to him, maybe even his true home, he left to take up a new position that had been offered to him. This was at Charles Ferdinand University in Prague, which is in what we now call Czechia or the Czech Republic. But back then, it was a constituent part of the vast Austro-Hungarian Empire, that sprawling, multilingual empire that dominated Central Europe. The position came with something else too, an offer of Austrian citizenship. So once again, Einstein was changing national identities, shifting his legal status, crossing borders. He was becoming this truly international figure, belonging to no single place. Although he only spent a little over a year in Prague, just about 13 or 14 months, he was incredibly, remarkably productive during that time. He published upwards of a dozen papers, serious academic papers, on topics ranging from the mathematics of radiation to quantum theory to gravitation. His mind was just constantly churning, constantly working on these deep problems about the nature of reality. But before long, before he could really settle into Prague and make it home, a new offer came along that pulled him back to Switzerland like a magnet. This was an invitation to teach at his old alma mater, the place where it had all really begun for him, the Swiss Federal Polytechnic School in Zurich, the place where he'd studied as a young man, where he'd met Malva, where his passion for physics had truly crystallized. He was back there by the summer of 1912, walking the same halls he'd walked as a student, and he spent the next year lecturing to classes full of students who were increasingly familiar with, increasingly in awe of, the growing international fame of this German physicist who was now their professor. And of course, he continued researching, always researching. Problems related to gravitation, questions about molecular heat, the deep structure of matter and energy. Much of this latter work, this research on gravitation especially, was undertaken in close collaboration with Marcel Grossmann. Remember that name. He was the Swiss colleague who had attended the Polytechnic with Einstein way back in the late 1890s, when they were both young students trying to figure out their futures. And Grossmann's family had helped Einstein acquire that earlier position at the Bern Patent Office, had used their connections to get him that job when nobody else would hire him. So they went way back, these two. Real friendship, real intellectual partnership. Then in the spring of 1913, less than a year after Einstein had taken up his position back in Zurich, something significant happened. Einstein was visited at his home in Switzerland by two men, Max Planck and Walther Nernst. These were two of the absolute foremost scientists of the entire age, giants in their fields. Both of them worked in Berlin, which was the intellectual capital of Germany, maybe of all Europe at that time. And they had come all the way to Zurich with a specific mission: to convince Einstein, to persuade him, to return to Germany, to the land of his birth, the country he'd left as a teenager and then renounced. They wanted him to take up a prestigious position at the University of Berlin. And it wasn't just a teaching position. The offer came with automatic membership in the Prussian Academy of Sciences, one of the oldest and most respected scientific institutions in the world, as well as his appointment as director of the Kaiser Wilhelm Institute for Physics, a major research institution that was being established. This new role would allow Einstein to concentrate purely on his research, to focus entirely on pushing the boundaries of physics without worrying about teaching loads or administrative duties. He could build a team of researchers around him, bright young minds who could help him explore these deep questions. It was an offer he really couldn't refuse. The opportunity was just too good, and honestly it was made even more attractive, even more appealing, by the prospect of being close to his cousin Elsa. She lived in Germany, in Berlin actually, and Einstein had begun corresponding with her frequently, writing her long letters since the spring of 1912. They'd been growing closer through their letters. There was clearly something developing between them, some kind of romantic connection, or at least emotional intimacy. So in early 1914, at the beginning of that fateful year, Albert made the move to the German capital, to Berlin. His first wife, Malva, agreed to move at first with their two sons, Hans Albert and Eduard. They packed up their lives in Switzerland and headed to Germany as a family. But Malva was immediately unhappy in Berlin. Right from the start, from the moment they arrived, she didn't like it. She could sense, probably correctly, that Albert was growing emotionally closer to his cousin Elsa. She could feel the distance opening up between them, the marriage crumbling, and Berlin itself didn't feel right to her. The culture, the people, the atmosphere, she didn't belong there. So fairly quickly, she made the painful decision to return to Zurich with their children, to take the boys and go back to Switzerland. They remained separated, living in different countries, for 5 long years after that, from 1914 until 1919. Finally, in 1919, they officially divorced, ending a marriage that had been over in all but name for years. That same year, almost immediately after the divorce was finalized, Einstein married Elsa, his cousin. By then both of them were in their 40s, not young anymore, middle-aged really. This second marriage of Einstein's did not result in any further biological children. They didn't have kids together, but Albert did become stepfather to Elsa's 2 daughters from her previous marriage, taking on that parental role. Now, Einstein's arrival in Berlin in early 1914 was immediately interrupted, overshadowed by something massive, something that would reshape the entire world: the outbreak of the First World War. For years, really for decades, tensions had been building steadily between the major European powers: Britain, France, Germany, Russia, Austria, Hungary. The reasons were complex, tangled, overlapping. Colonial rivalry in Africa, where these European empires were competing for territory and resources. The power vacuum left by the slow, painful collapse of Ottoman power in the Balkans, in southeastern Europe. The intense naval arms race between Britain and Germany, both countries building bigger and bigger fleets of warships, dreadnoughts bristling with guns. All of these tensions, all of this accumulated hostility and competition, coalesced in the summer of 1914 into the outbreak of a pan-European war. What started as a regional conflict quickly became a worldwide catastrophe, pulling in nations from every continent. When the war erupted in August 1914, when Germany invaded neutral Belgium as a strategic move, as a means of striking quickly at northeastern France through Belgian territory, this invasion drew widespread international condemnation. It was seen as a violation of international law, of basic norms. Belgium was neutral. They hadn't done anything. In response to this criticism, a document started being circulated within Germany. It was called the Manifesto of the 93, and it was addressed grandly to the civilized world. The movement was led by prominent figures like Adolf von Beer, who had won the Nobel Prize in Chemistry back in 1905, and Paul Ehrlich, who had won the Nobel Prize in Medicine in 1908 for his pioneering, groundbreaking work in chemotherapy, in using chemicals to fight disease. This manifesto was effectively a public letter from dozens and dozens of prominent German academics, intellectuals, scientists, scholars, sounding their full support for Germany's war effort, saying that Germany was in the right, that the invasion was justified, that the world should support Germany. Einstein, true to his deepest principles, refused to sign it. He wouldn't put his name on it. He was a lifelong pacifist, someone who believed deeply that violence was wrong, that war was a failure of humanity. He couldn't support the war, couldn't endorse the killing, no matter what political justifications were offered. Instead, Einstein and several other German academics who shared his views drew up their own counter-document. They called it the Manifesto to the Europeans. This document expressed a different idea entirely. It said that Europe's sense of common culture, the shared heritage and values that connected all European peoples, could be harnessed, could be used as a foundation to bring the war to a swift end. That reason and shared humanity could triumph over nationalism and violence. Unfortunately, sadly, their hopes were not met. Their plea fell on deaf ears. The war was not swift. It dragged on for 4 more brutal, terrible years of interminable conflict. Trench warfare, poison gas, machine guns mowing down waves of young men, millions upon millions dead, an entire generation lost. And even after the armistice in 1918, years more of revolution and civil war erupted across much of the continent. Russia, Germany, Hungary, Ireland. The violence just continued and continued. Despite the ongoing war, despite the chaos and death all around, Einstein was able to commence new research in a concerted, focused manner in Berlin from 1915 onwards, once the initial shock of the war's outbreak had lessened a bit, once some kind of routine had been re-established. However, it was not until 1917, 3 years into the war, that the Kaiser Wilhelm Institute was finally formally established in Berlin with Einstein as its first director, its founding leader. Funding delays and administrative complications wrought by the massive war effort by the strain the war put on every aspect of society, had delayed its inception, pushed it back again and again. But once it was established, Einstein would serve as head of the institute as its guiding force for the next 16 years, a long tenure. Meanwhile, in 1916, he was admitted as a member of the German Physical Society, which had been established way back in 1845 and holds the distinction of being the world's oldest major academic organization of physicists. So he was joining a lineage, becoming part of a tradition that stretched back decades. Foreign honors would also follow in the years ahead, recognition from institutions around the world, including membership in the Royal Netherlands Academy of Arts and Sciences in 1920, and admittance as a foreign member in 1921 to the Royal Society in London, arguably the single most prestigious scientific society in the entire world, an institution with an incredible history that dated all the way back to 1660, when it was founded in London during the English Restoration. Such honors aside, beyond the medals and the memberships, Einstein continued to break genuinely new ground in his research during the mid to late 1910s, even with a world war raging around him. For instance, in 1916, he did something remarkable. He hypothesized, he predicted mathematically, the existence of gravitational waves. These are effectively ripples in the curvature of spacetime itself, like ripples spreading across a pond, but the pond is the fabric of reality. Disturbances in spacetime caused by massive objects moving or colliding, spreading outward at the speed of light. Now here's the thing, these gravitational waves could not be detected, could not be measured or confirmed, using any of the instrumentation that was available in the early 20th century. The technology simply didn't exist. They were too subtle, too faint, so it remained a prediction, a hypothesis for decades and decades. But then, a full century later, in 2016, 100 years after Einstein first predicted their existence, they were finally confirmed experimentally by American scientists using incredibly sophisticated detectors called LIGO. These detectors can measure distortions in spacetime smaller than the width of a proton, and they detected gravitational waves from two black holes colliding over 1 billion light-years away. Einstein had been right all along. A century later, his prediction was vindicated. He was also beginning to theorize about the existence of what we now know and call black holes. These are points, regions in space, where gravity becomes so incredibly strong, so overwhelming, that neither light nor particles can effectively escape from them. Nothing can get out, and they distort space and time around them in extreme ways, warping the very fabric of reality. As with so much else in Einstein's work, his early theoretical work on black holes was pioneering, foundational. It paved the way for many of his successors, for generations of physicists who came after him, to produce detailed accounts, comprehensive models of these strange objects. Black holes became central to our understanding of the universe later in the 20th century, and Einstein had laid the groundwork. But he could be wrong too. Einstein wasn't infallible. He made mistakes like anyone else. In 1917, he began working on what he termed the cosmological constant. This was a theory, an addition to his equations of general relativity, which supposed the existence of a static universe. A universe that wasn't expanding or contracting, just sitting there, eternal and unchanging. Many years later, when an American astronomer named Edwin Hubble made a discovery about the recession of nebulae in the universe, about how galaxies were moving away from us, Einstein realized his earlier theory of the cosmological constant was incorrect. It was wrong. The universe wasn't static at all. It was expanding, and not just expanding but accelerating. Einstein referred to the cosmological constant, this mistaken theory, as his biggest blunder throughout the rest of his career. He was embarrassed by it, though interestingly, modern cosmology has actually brought back a version of the cosmological constant in the form of dark energy, so maybe he wasn't as wrong as he thought, but that's getting ahead of the story. His other great research project of the war years, though, was far from a blunder. It was anything but a mistake. Einstein had been working on the concept of relativity for over a decade by this point. Special relativity was the subject of one of those acclaimed papers from his miracle year of 1905, but that was just the beginning, just the first step. It was not until the mid-1910s, during the First World War, that he began finalizing his research on the subject of general relativity. Pulling it all together, working out all the mathematics, making sure everything was consistent and coherent. General relativity it's hard to even describe how profound it is. It outlined a geometric theory of gravitation. This moved far, far beyond Newtonian ideas concerning gravity, beyond the idea that gravity is just a force pulling things together. Einstein showed that gravity is actually the curvature of spacetime itself, caused by mass and energy. Massive objects like stars and planets don't pull on other objects. Instead, they warp the space and time around them, creating curves and dips in the fabric of spacetime, and other objects move along those curves. They're following the natural paths through curved spacetime. It's like putting a bowling ball on a trampoline. The bowling ball creates a dip, a depression, and if you roll a marble nearby, it will curve toward the bowling ball, not because the bowling ball is pulling it, but because it's following the curved surface of the trampoline. This explained gravitational pull and the full complexity of geometric gravity as it applies not just to individual planets, but to the entire universe, to the cosmos as a whole. Now there's an ongoing debate, one that historians and physicists still discuss, about who actually arrived at the general theory of relativity first. Because Einstein had a contemporary, a brilliant German mathematician named David Hilbert, who was working on essentially the same problem at the same time. And Hilbert arrived at nearly identical conclusions, almost the exact same mathematical formulation, as Einstein did in the mid-1910s. It's kind of like what happened with Charles Darwin and Alfred Russel Wallace in the 19th century, way back in the 1850s. Both of them broadly developed the theory of natural selection, the mechanism for evolution, at the same time, independently but with some communication between them. Einstein and Hilbert were in communication with each other too. They knew what the other was working on. Einstein had actually visited the University of Göttingen, where Hilbert was working and teaching, in 1915. He went there specifically to present lectures on his own findings, to share his work in progress. So they were influencing each other, exchanging ideas. What seems relatively clear, based on the historical record we have, is that Einstein and Hilbert influenced each other sufficiently, shared enough insights and approaches, that they both arrived at essentially the same conclusions concerning general relativity within just days of each other in the winter of 1915. It's hard to say who was truly first. Maybe it doesn't even matter. They were both brilliant. They were both working at the absolute cutting edge of human knowledge. In late 1918, finally, after 4 years of unimaginable carnage, Europe and the wider world began to emerge from the terrible grip of the First World War. The armistice was signed in November. The guns fell silent. Although, and this is important to note, in some countries the end of the World War saw the commencement of bitter, vicious civil wars that in some ways eclipsed anything that those countries had experienced during the war itself. Russia descended into a brutal civil war between the Reds and the Whites, between Bolsheviks and various counter-revolutionary forces. Hungary had a revolution and counter-revolution. Turkey had years of warfare. Ireland fought for independence and then fell into civil war. But in most places, gradually, some form of normal life began to resume. Academic discourse started up again in earnest. Research began to be disseminated widely again, crossing borders, being translated, being discussed. The scientific community started to reconnect. Thus, Einstein and Hilbert's work on the general theory of relativity finally reached a wider audience within the community of Europe and America's physicists. It had been published during the war, but with everything in chaos, with countries cut off from each other, with journals not circulating normally, many people hadn't seen it or studied it carefully yet. As it spread, as people read it and worked through the mathematics and understood the implications, there was an increasing appreciation, a growing sense of awe at how genuinely groundbreaking their studies were. This wasn't just an incremental advance. This was a complete reconceptualization of gravity, of space, of time, of the structure of the universe. Then, in the summer of 1919, something extraordinary happened that would make Einstein world famous, that would turn him from a respected scientist into a global celebrity. The theory was confirmed as being accurate by Sir Arthur Eddington, an English astronomer and mathematician, during a total solar eclipse. Eddington led an expedition to observe the eclipse, and he was specifically looking to test Einstein's prediction that light from distant stars would be bent, would curve, as it passed near the Sun due to the Sun's gravity warping spacetime. And that's exactly what Eddington observed. The positions of stars near the Sun appeared shifted, exactly as Einstein had predicted. General relativity was correct. The observations matched the theory perfectly. This time, for the first time really, the popular newspapers picked up the story. Not just academic journals that nobody outside universities read, but actual mainstream newspapers. Headlines proclaimed that Einstein's theory had overthrown the model of the universe that had been developed by Isaac Newton nearly 250 years earlier, way back in the 1680s. Newton was practically a god in the scientific world. His laws had been unquestioned for centuries. And now this German physicist, this guy working in Berlin, had shown that Newton's picture was incomplete, that reality was stranger and more subtle than Newton had imagined. Given all of this excitement, all this international attention, it's perhaps unsurprising that in 1921, just 2 years after the eclipse confirmation, the Nobel Foundation in Stockholm, Sweden, decided to award Einstein the Nobel Prize for Physics, the highest honor in science, the prize everyone dreams of. Interestingly, they specifically cited his work in discovering and explaining the photoelectric effect in his paper from way back in 1905 in the award designation. Not general relativity, which was probably his most famous work by that point, but the photoelectric effect. Though honestly, the prize could just as easily have been awarded for a wide range of research findings over the previous 15 or so years. Einstein had revolutionized multiple fields. He deserved multiple Nobel Prizes, really. Receipt of the Nobel Prize in 1921, combined with the opening up of the world during the boom years of the 1920s, after years of war and social discord and closed borders, saw Einstein and Elsa, whom he had just recently married after divorcing Milva, decide to travel internationally, to see the world, to meet people, to share ideas. In early April of 1921, they sailed across the Atlantic Ocean into New York City, into New York Harbor. And the reception was incredible. They were greeted by the mayor himself, John Francis Hylan, and a delegation of some of the most senior, most respected members of the city's large and influential Jewish community. Einstein was becoming not just a scientific figure, but a cultural icon, especially within the Jewish diaspora. Weeks and weeks of lectures and receptions followed, just a whirlwind tour. He spoke at Columbia University in Manhattan in New York to packed lecture halls. He visited Princeton University in New Jersey, which would later become so important in his life. Students and faculty crowded in to hear him speak, to catch a glimpse of this genius who'd rewritten physics. Later that month, toward the end of April, Einstein did something remarkable. He met President Warren Harding at the White House in Washington, D.C. Can you imagine? This former patent clerk, this stateless refugee who'd renounced his German citizenship, now meeting the President of the United States. Afterwards, Einstein and Elsa left the United States and embarked on a Pacific voyage, sailing west across the vast ocean. They visited the Empire of Japan, where Einstein was treated like royalty, where his lectures drew enormous crowds. Then onwards to Singapore, that tropical port city, a crossroads of cultures. And then to India, the jewel of the British Empire, where Einstein saw poverty and richness side by side, where he encountered a completely different civilization. Before returning home, they reached the Middle East. There, Einstein visited Palestine, which had become subject to a British mandate, British control, following the end of the First World War and the collapse of the Ottoman Empire. This was where the Jewish Zionist movement was actively attempting to establish a new state for the world's Jewish people after centuries, really after nearly 2 millennia, of being scattered around the globe, living in diaspora. Einstein was moved by what he saw there, the pioneers, the settlers, trying to build something new in an ancient land. Afterwards, he returned to Germany, back to Berlin. But this trip in 1921 and 1922 was just the beginning of a pattern, the start of significant trips to different parts of the world that would continue throughout the decade. For instance, in 1925, Einstein visited South America, the continent he'd never seen before. He spent weeks in Argentina, in Buenos Aires especially, giving lectures and meeting with academics. Then Uruguay, across the Rio de la Plata. and Brazil, that vast Portuguese-speaking country. These were nations that were booming economically and socially in the early 20th century, places of optimism and growth. And Einstein was absolutely revered within their academic communities. He was treated like a visiting dignitary, like intellectual royalty. In the mid-1920s, Einstein also became involved in a scientific debate, a dispute that was widely reported on at the time that captured public imagination. This was between himself and Niels Bohr, a Danish physicist who was equally brilliant, equally accomplished. Bohr had won the Nobel Prize in Physics in 1922, just 12 months after Einstein had been awarded the same honor. So these were the two giants of physics, the two titans, going head-to-head. A dispute had been building between Einstein and Bohr throughout the mid-1920s over their differing interpretations of quantum theory, over what quantum mechanics actually meant, what it said about reality. Much of this centered initially on Bohr's refusal to believe that photons, those particles of light that Einstein had first theorized the existence of way back in 1905, were actually real physical things. Bohr thought they were just mathematical constructs, just useful fictions. He did not accept that photons existed as real entities until 1925, fully 20 years after Einstein proposed them. And even then, even after he accepted photons were real, their debates raged on intensely over other elements of their respective views on quantum mechanics. They disagreed about the nature of reality at the quantum level, about whether quantum mechanics was complete, or whether there was some deeper theory underneath. Debates were held in various locations, in London, in Copenhagen, in Berlin, between 1922 and 1925, but the disagreements culminated in a famous, legendary academic disputation in 1927 at the Fifth Solvay Conference. This was held at the International Solvay Institutes of Physics and Chemistry in Brussels, Belgium. Here, Einstein and Bohr continued their debate intensely, passionately, both figures arguing points, making cases that eventually proved to be partially accurate, partially correct. They were both seeing different aspects of a deeper truth, really. But beyond the theoretical arguments themselves, beyond the actual content of the debate, the Fifth Solvay Conference is genuinely noteworthy for the sheer number of the world's most accomplished physicists that it drew together in one place at one time. It's become this iconic photograph, this image that represents the golden age of physics. 17 of the 29 attendees at that conference had already received, or would later receive, Nobel Prize awards. Just think about that. 17 Nobel Prize winners in one room. The density of genius was extraordinary. Einstein and Bohr were there, of course, the two giants, but they were joined by figures including Marie Curie, the only person to win Nobel Prizes in two different sciences, physics and chemistry, Werner Heisenberg, who would formulate the uncertainty principle, Erwin Schrödinger of Schrödinger's cat fame, Max Planck, the founder of quantum theory, Louis de Broglie, Max Born, Paul Dirac, the list goes on and on. It points to, it reveals, the sheer level of brilliance, the concentration of intellectual firepower in the European scientific community during the interwar period, during the 1920s and 1930s. It was a golden age. Never before or since has there been such a gathering of minds. The late 1920s also saw Einstein reconceptualizing his own theories of the universe, rethinking some of his earlier ideas. This was in direct response to the discovery by the American astronomer Edwin Hubble of the recession of the nebulae, a phenomenon that's now termed Hubble's law in his honor. What Hubble discovered, through painstaking observations using the most powerful telescope in the world at the time, was this. Galaxies, these vast collections of billions of stars, are moving away from Earth. They're receding, getting farther away. And not just moving away, but moving away at speeds that are proportional to their distance from us, from the Milky Way. The farther away a galaxy is, the faster it's moving away, always faster, which means that the universe itself is expanding, swelling like a balloon being inflated. Space itself is stretching. These findings, which were made public in 1929, required Einstein to abandon his current theory of the universe at that time. That cosmological constant theory I mentioned earlier, which supposed that the universe was largely static in the way that it expanded, that the cosmos had been expanding since the Big Bang at a relatively constant, steady speed, neither accelerating nor decelerating. Hubble's discoveries forced Einstein to re-evaluate his hypothesis completely, to admit he'd been wrong. because it was now clear, observationally proven, that the universe was not static at all. It was expanding at an ever greater speed, accelerating in its expansion. Einstein called this his biggest blunder, remember, but he was humble enough to admit when he was wrong, to change his mind when the evidence demanded it. That's actually a mark of a true scientist. Hubble's discovery was also partly responsible for Einstein's decision to embark on another journey to the United States in December of 1930. He wanted to meet Hubble in person, to thank him for his research, for his observations that had corrected Einstein's error. And he did meet him in 1931, in California, and they had long discussions about the nature of the cosmos. However, this trip is generally more remembered by historians, more famous, for Einstein's visit to California, where the ostensible purpose of the voyage, the official reason, was to take up a 2-month visiting fellowship at the California Institute of Technology, Caltech as it's known today, one of the world's premier scientific institutions. During this sojourn in sunny California, during these weeks on the West Coast, Einstein ominously noted, he made a dark observation. He said that science had as much, and perhaps even a greater, capacity to do harm than to do good within human society. This was a reference, no doubt, to the increasing use of technology in warfare, to the militarization of science. The First World War had seen poison gas, tanks, airplanes used as bombers, submarines, science weaponized, and Einstein, the lifelong pacifist, found this trend absolutely abhorrent, deeply troubling. This same aversion to the growing militarism of the 1930s, to the dark clouds gathering over Europe again, led Einstein to feel an affinity with certain other figures who shared his views. The novelist Upton Sinclair, known for his muckraking journalism and his exposés of social injustice, and the actor Charlie Chaplin, the silent film star, beloved around the world, both of whom Einstein met in Los Angeles during his visit. And both of whom were publicly affirmed pacifists themselves, vocal opponents of war. Einstein's growing friendship with Charlie Chaplin, this relationship that developed, led him to attend the premiere of Chaplin's new film in Hollywood. It was called City Lights, a silent film even though talkies had already been invented, and it was significant in establishing the romantic comedy genre in American movies, in world cinema really. When Albert and Elsa Einstein entered the cinema with Chaplin for that premiere, when they walked down the aisle, Einstein was cheered by the crowd with the same fervor, the same enthusiasm, that a Hollywood icon, that a movie star could obtain. He was mobbed. People wanted to shake his hand, to touch him. He'd become that famous, that recognizable. It was also the beginnings of a long, lasting friendship between Einstein and Chaplin that saw the actor visit Einstein's Berlin apartment shortly afterwards, when Chaplin was touring Europe. And Einstein renewed their acquaintance when he himself returned again to America early in 1933, not knowing it would be the last time he'd see Europe. While Einstein had been holding his various positions in Germany and traveling widely across the world in the 1920s and early 1930s, as his fame and his accomplishments grew year by year, as he became this global figure, the political environment back in his native Germany, the country of his birth, was changing for the worse. Dramatically, terrifyingly for the worse. Germany had been mired in political chaos and economic instability in the aftermath of the First World War. The Treaty of Versailles had imposed harsh terms: reparations, territorial losses, limits on the military. The German people felt humiliated, defeated, angry. But from 1923 onwards, Germany had managed to enter into a period of relative prosperity and stability. The Weimar Republic seemed to be working. The economy grew, culture flourished. Berlin became this amazing center of art and science and nightlife. That seeming stability was shattered violently in late 1929 when the stock markets on Wall Street in New York City crashed spectacularly, losing almost half their value in just weeks. And a massive economic depression, the Great Depression, set in across the entire developed world. Global trade collapsed, banks failed, businesses went bankrupt. In Germany, as millions and millions of people lost their jobs and their economic security, as soup kitchens opened and people stood in bread lines, as savings evaporated and hope died, a huge proportion of the population turned in desperation in national elections to an extremist political party, the rabidly anti-Semitic National Socialist German Workers' Party, the Nazis under their leader, their Führer, Adolf Hitler. In Reichstag elections in 1932, elections for the German parliament, the Nazis became the largest political party in Germany. Not a majority, but the largest single party. And in the first months of 1933, through a combination of political maneuvering and intimidation, Hitler became Chancellor of the country, the head of the government. Within mere weeks, the Nazi Party effectively turned Germany into a one-party, totalitarian, fascist state. They suspended civil liberties. They banned other political parties. They took control of the police and the courts. Democracy died almost overnight. This was extremely ominous, deeply threatening for the country's Jewish population. For individuals like Einstein, people of Jewish heritage, the Nazis blamed Jews for Germany's problems. They propagated vicious anti-Semitic conspiracy theories. They passed laws restricting what Jews could do where they could work. Einstein was in the United States when Hitler seized power in early 1933. He'd been visiting, giving lectures, and he made a fateful decision. He decided not to return to Germany, just decided he wouldn't go back. Instead, the Einsteins settled in America, though they made a brief stop first in Antwerp in Belgium. There, Albert went to the German embassy and did something symbolic and definitive. He handed his German passport in to the embassy officials and formally renounced his citizenship. For the second time in his life, he was giving up German nationality, walking away from the country of his birth. Back in Berlin, in the Germany he'd left behind, the Nazis had already searched his apartment twice on account of his Jewish heritage, looking for evidence of treason or disloyalty or anything they could use against him. And over the next year or so, over 1933 and 1934, Jewish academics such as himself, Jewish professors and teachers and researchers, were systematically forced out of their positions across Germany. Expelled from universities, fired from research institutes, Jewish students were banned from schools. It was the beginning of a nightmare that would culminate in the Holocaust, in the attempted extermination of European Jewry. In the United States, following his decision to seek permanent residence there in 1933, Einstein quickly, relatively easily, acquired a position at the Institute for Advanced Study at Princeton University in New Jersey. This is a special kind of institution, not really a normal university. It's a research institute where brilliant scholars are given positions with no teaching duties, no administrative responsibilities. They're just expected to think, to research, to pursue knowledge. It was the institution which Einstein would spend the longest portion of his entire career at. And barring a brief directorship at Brandeis University in Massachusetts, a Jewish university, in the mid-1940s, Einstein was primarily associated with Princeton, with that leafy New Jersey college town, for the remainder of his life for over 20 years. In the mid to late 1930s, during these years in America, Einstein undertook some further notable work on the East Coast, continuing to push boundaries even as he entered his 50s and then his 60s. A particularly significant engagement, a particularly interesting collaboration, resulted from working together with Nathan Rosen, a Jewish-American physicist. Together, Einstein and Rosen produced a theoretical model of what a wormhole might look like, what the structure of such a thing might be. Wormholes are theoretical constructs, hypothetical structures that might connect disparate, separated points in spacetime together, like shortcuts through the universe, tunnels that could theoretically let you travel vast distances instantly. In 1911, Einstein left Switzerland. He'd been there for over 15 years at that point. He took a position at Charles Ferdinand University in Prague, which was part of the Austro-Hungarian Empire then. It's in Czechia now. They even offered him Austrian citizenship as part of the deal. He was only there for about a year, but he was incredibly productive. He published more than a dozen papers on radiation, quantum theory, and gravitation. Then in 1912, he got an offer he couldn't refuse. Come back to Zurich, teach at the Polytechnic School, your old alma mater. So he went. He spent a year there, lecturing to students who were increasingly aware of just how famous he was becoming. He also worked with his old friend Marcel Grossmann on problems related to gravitation and molecular heat. In the spring of 1913, though, something bigger came calling. Two scientists, Max Planck and Walther Nernst, came to visit Einstein in Switzerland. Both of them worked in Berlin and were hugely respected. They came with an offer. Come to Berlin, teach at the University of Berlin. you'll automatically become a member of the Prussian Academy of Sciences, and you'll be the director of the Kaiser Wilhelm Institute for Physics. You can focus purely on research, build your own team. Oh, and Berlin was where Einstein's cousin Elsa lived. He'd been writing to her frequently since 1912. They were getting close. Einstein couldn't turn it down, so in early 1914 he moved to Berlin. Malva agreed to come at first, bringing their 2 sons, but she hated Berlin immediately. She could tell Albert was growing closer to Elsa. So Malva took the boys and went back to Zurich. They stayed separated for 5 years, finally divorcing in 1919. That same year, Einstein married Elsa. They were both in their 40s by then. No more children, but Albert became stepfather to Elsa's 2 daughters from her previous marriage. But right when Einstein arrived in Berlin in 1914, the world exploded. World War I began. All the tensions that had been building for years, colonial rivalry in Africa, the collapse of Ottoman power in the Balkans, the naval arms race between Britain and Germany, all of it came to a head in the summer of 1914. Germany invaded Belgium to get to France, and Britain and France declared war. It became a massive, brutal conflict that would last 4 years and kill millions. When the war started, a bunch of prominent German academics signed something called the Manifesto of the 93. It was addressed to the civilized world, and it basically said, "We support Germany's war effort." Nobel Prize winners signed it, famous scientists and scholars. Einstein refused. He was a pacifist, always had been. Instead, he and a few other academics wrote the manifesto to the Europeans. This one said, "Hey, maybe we can use our shared European culture to end this war quickly. Let's stop the killing." Unfortunately, that didn't happen. The war dragged on for 4 more years. Millions died in trenches. Revolutions broke out. It was catastrophic. Despite the war, Einstein started doing serious research again in Berlin from 1915 onward, though the Kaiser Wilhelm Institute didn't actually get established until 1917 because of delays caused by the war. Once it did, Einstein became its first director. He'd stay in that role for 16 years. In 1916, he was admitted to the German Physical Society. That's the world's oldest major organization of physicists, founded way back in 1845. And foreign honors started rolling in too. The Royal Netherlands Academy in 1920, the Royal Society in London in 1921. That's one of the most prestigious scientific organizations in the world, founded in 1660. But beyond the honors, Einstein kept breaking new ground. In 1916, he predicted the existence of gravitational waves. These are basically ripples in the fabric of space-time itself. Problem was they were impossible to detect with the technology of the early 1900s. But 100 years later, in 2016, American scientists finally detected them. Einstein had been right all along. He was also theorizing about black holes, places in space where gravity is so intense that not even light can escape. These objects warp space and time around them. Einstein's early work on black holes paved the way for everything we understand about them today. He wasn't always right, though. In 1917, he started working on something he called the cosmological constant. This was a theory that supposed the universe was static, not really expanding or contracting, just kind of there. Years later, an American astronomer named Edwin Hubble discovered that galaxies were actually moving away from us, and the farther away they were, the faster they were moving. The universe was expanding. Einstein realized his cosmological constant was wrong and called it his biggest blunder. Even geniuses make mistakes. But his other big project during the war years was no mistake at all. Einstein had been thinking about relativity for over a decade. Special relativity was just the beginning. Now he was working on general relativity. General relativity is about gravity and how massive objects warp space and time. Newton had talked about gravity as a force that pulled things together. Einstein showed that gravity is actually the curving of space-time caused by mass. A planet doesn't pull you down. It curves the space around it, and you fall along that curve. There's a debate about whether Einstein actually arrived at general relativity first. A German mathematician named David Hilbert was working on the same problem at the same time. Kind of like how Charles Darwin and Alfred Russel Wallace both developed the theory of natural selection around the same time in the 1850s. Einstein had visited the University of Göttingen in 1915 to present his work. Hilbert was there. They talked, exchanged ideas, and then both of them arrived at nearly identical conclusions within days of each other in the winter of 1915. It's pretty clear they influenced each other. They were both brilliant, and they were working on the same cutting-edge problem. So credit goes to both of them, really. In late 1918, World War I finally ended. Well, sort of. In some places like Russia, Hungary, and Ireland, civil wars erupted that were even worse than the war itself. But academic life started returning to normal. Research began circulating again. Einstein and Hilbert's work on general relativity reached a wider audience, and physicists started to realize just how groundbreaking it was. Then in the summer of 1919, something incredible happened. An English astronomer and mathematician named Sir Arthur Eddington confirmed the theory during a solar eclipse. He observed that light from distant stars was being bent by the sun's gravity, exactly as general relativity predicted. The popular newspapers picked up the story. Headlines proclaimed that Einstein had overthrown Newton's model of the universe. Newton had been the gold standard for nearly 250 years, and now Einstein was showing that reality was even stranger and more beautiful than we'd imagined. So in 1921, the Nobel Foundation in Stockholm awarded Einstein the Nobel Prize for Physics. They specifically cited his work on the photoelectric effect from 1905, but honestly, they could have given it to him for half a dozen different discoveries. Winning the Nobel Prize changed things. Einstein and Elsa started traveling the world. In April 1921, they sailed into New York City. The mayor greeted them. Senior members of the Jewish community threw receptions. Einstein gave lectures at Columbia University in Princeton. He met President Warren Harding at the White House. Then they sailed to Japan, Singapore, India, and eventually the Middle East. In Palestine, which was under British control after World War I, Einstein saw the beginnings of the Zionist movement. Jewish people from around the world were migrating there, trying to establish a homeland after centuries of being scattered. Einstein went back to Germany, but the 1921 to 1922 trip was just the beginning. In 1925, he visited South America, Argentina, Uruguay, Brazil. These countries were booming, and Einstein was treated like a rock star in academic circles. In the mid-1920s, Einstein got into a famous scientific debate with Niels Bohr, a Danish physicist who'd won the Nobel Prize in 1922, right after Einstein. They disagreed about quantum theory. Bohr didn't believe photons were real, even though Einstein had theorized them back in 1905. Bohr didn't accept they existed until 1925, and even then they kept arguing about other aspects of quantum mechanics. Their debates happened in London and elsewhere, but the most famous one was in 1927 at the Fifth Solvay Conference in Brussels. This conference is legendary. 29 attendees, and 17 of them were either Nobel Prize winners already or would become Nobel Prize winners later. Einstein and Bohr were there, along with Marie Curie, Werner Heisenberg, Erwin Schrödinger. Just an absolutely stacked lineup of brilliant minds. Both Einstein and Bohr made arguments that turned out to be correct, by the way. They were both right about different things. That's how complex this stuff was. The late 1920s forced Einstein to rethink some of his own theories. Edwin Hubble, that American astronomer I mentioned earlier, discovered what's now called Hubble's law. Galaxies are moving away from Earth, and the farther away they are, the faster they're moving. This meant the universe was expanding at an accelerating rate. Einstein had to abandon his cosmological constant, that theory about a static universe. Hubble's discovery showed the universe was dynamic, constantly expanding faster and faster. In December 1930, Einstein decided to visit the United States again. He wanted to meet Hubble and thank him personally for his groundbreaking work, which he did in 1931. But the trip is more famous for Einstein's visit to California. He took a 2-month fellowship at the California Institute of Technology, Caltech. While he was there, Einstein made an ominous observation. He said science had as much capacity to do harm as to do good. He was talking about technology in warfare. For a pacifist like Einstein, the increasing militarization of the world was horrifying. He met some interesting people in Los Angeles. Upton Sinclair, the novelist, and Charlie Chaplin, the actor. Both were outspoken pacifists like Einstein. He and Chaplin became good friends. Einstein even attended the premiere of Chaplin's new film, City Lights. It was a silent romantic comedy that helped establish the genre in American cinema. When Einstein walked into that theater with Chaplin, the crowd cheered for him like he was a movie star. That's how famous he'd become. Chaplin visited Einstein's apartment in Berlin shortly after, and Einstein would meet up with him again when he returned to America in early 1933. But while Einstein had been traveling and doing research in the 1920s and early 1930s, things back in Germany were getting dark, really dark. After World War I, Germany had been in political chaos, but from 1923 onward, there was a period of prosperity and stability. Then in late 1929, the stock markets crashed on Wall Street in New York. The Great Depression hit. Millions lost their jobs across the developed world. In Germany, as people's economic security evaporated, they turned to extremism. The National Socialist German Workers' Party, the Nazis led by Adolf Hitler, started gaining power. They were rabidly anti-Semitic. They blamed Jews for Germany's problems. In 1932, they became the largest party in the Reichstag, and in early 1933, Hitler became Chancellor. Within weeks, Germany became a one-party fascist state, and it was extremely dangerous for Jewish people like Einstein. Einstein was in the United States when Hitler took power. He made a decision. He wasn't going back. He made a brief stop in Antwerp, Belgium, where he went to the German embassy and handed in his passport. He renounced his citizenship for the second time in his life. Back in Berlin, the Nazis had already searched his apartment twice because he was Jewish. Over the next year, Jewish academics were systematically forced out of their positions across Germany. In the US, Einstein quickly got a position at the Institute for Advanced Study at Princeton University in New Jersey. This would be his home base for the rest of his life. He'd have a brief directorship at Brandeis University in Massachusetts in the mid-1940s, but Princeton was where he belonged. In the mid to late 1930s, Einstein did some fascinating work on the East Coast. One particularly notable project was with Nathan Rosen, a Jewish-American physicist. Together, they produced a model of what a wormhole might look like. Wormholes are theoretical structures that could connect different points in space-time, like shortcuts through the universe. At the time, they were a relatively new concept, but they became fundamental to theoretical physics and later to science fiction. Einstein and Rosen's wormhole bridge helped make that possible. Meanwhile, back in Germany, things were getting worse. After seizing power in 1933, the Nazis made it clear they wanted to overturn the Treaty of Versailles that had ended World War I. They started rearming, building tanks, planes, recruiting soldiers. In 1938, they annexed Austria. They took territory from Czechoslovakia and Lithuania. Then in September 1939, Hitler invaded Poland. Britain and France had finally had enough of appeasement. They declared war on Germany. World War II had begun. President Franklin Roosevelt didn't have public support for American involvement at first. Americans saw it as a European problem. But then in December 1941, Japan, Germany's ally, attacked Pearl Harbor in Hawaii. The US entered the war. And despite his pacifism, Einstein got involved. Actually, it started before the war even began in Europe. In early 1939, European physicists discovered nuclear fission using uranium. Suddenly, the possibility of a nuclear bomb became very real. A Hungarian physicist named Leo Szilard realized how dangerous this was. Germany had some of the world's best physicists. What if they built a nuclear weapon for Hitler? The Nazis wouldn't hesitate to use it. So Szilard and two other Hungarian physicists, Edward Teller and Eugene Wigner, wrote a letter to the US government warning them about this danger. They sent it to Einstein in America, and he signed it before they forwarded it to President Roosevelt. This Einstein-Szilard letter was influential. It led to the Manhattan Project, the US program to develop a nuclear weapon. The project started in a small way in late 1939, just weeks after Roosevelt got the letter. For Einstein, this went completely against his pacifist beliefs. But the alternative, the Nazis getting the bomb first, was even worse. Einstein didn't work on the Manhattan Project himself. It was led by Robert Oppenheimer, an American theoretical physicist. Between 1939 and 1941, the project was small, but once the US entered the war in December 1941, funding exploded. They discovered the Nazis were trying to develop superweapons too. In Norway, they were producing heavy water, a form of hydrogen that could potentially be used to make a nuclear bomb. British Special Forces and Norwegian resistance fighters sabotaged those efforts repeatedly. By the time of the sabotage missions, the Manhattan Project employed over 130,000 people. They built a nuclear reactor in Chicago in 1942, and then, in mid-July 1945, they detonated the world's first nuclear device in the New Mexico desert. By then, the war in Europe was over. Germany had surrendered in May, but the war in the Pacific against Japan was still raging. The Allies had agreed to focus on defeating Germany first, then deal with Japan. President Harry Truman made the decision to use the new weapon against Japan. The thinking was that it would force a quick surrender and ultimately save lives by avoiding a ground invasion that could kill over 1 million people. On August 6, 1945, a nuclear bomb was dropped on Hiroshima. It killed about 75,000 people the first day. Another 60,000 died in the months that followed from radiation sickness. 3 days later, a second bomb hit Nagasaki. About 80,000 people died. Japan surrendered quickly, but Einstein was appalled by the devastation. He said, "The time has come now when man must give up war. It is no longer rational to solve international problems by resorting to war." He expressed regret that his research, especially his work from 1905 on mass energy equivalence, had contributed to the development of these weapons. It haunted him. In the post-war years, Einstein kept researching, though he was nearing 70 and health issues were starting to limit him. At Princeton in the late 1940s, he developed his unified field theory. He published it in Scientific American in 1950 as on the generalized theory of gravitation. The goal was ambitious: create a single theoretical framework that could explain all the fundamental forces of nature. Gravity, electromagnetism, everything. Physicists had been trying to do this for decades, but nobody had succeeded. Einstein's theory tried to incorporate general relativity, electromagnetism, and gravity into a single origin point for all physical laws. He wanted to unify forces like gravitation and electromagnetic forces, even the curvature of space-time. Ultimately, his efforts and those of other physicists were unsuccessful in creating a truly unified theory, but his work is still considered important. It advanced differential geometry, the study of smooth shapes and surfaces, especially as they apply to space. After World War II, Einstein became a celebrity in mainstream American society in a way that was pretty much unprecedented for a theoretical physicist. Part of it went back to the 1920s, when the New York Times ran that story saying Einstein had destroyed space and time with his theories. It was presented as this fundamental overhaul of human understanding, as revolutionary as Darwin's theory of natural selection. But unlike Darwin, whose work was seen as sacrilegious when it came out, Einstein's work was celebrated. His friendships with people like Charlie Chaplin helped. His iconic appearance, the wild hair, made him instantly recognizable. And most importantly, by the 1940s, people could see how Einstein's ideas were changing the world in practical ways. Automatic doors that open when you walk up to them. That's because of Einstein's work on photons. Solar-powered calculators, Einstein, GPS, that relies on special relativity, nuclear power plants, mass energy equivalence. He became as famous as Stephen Hawking would be later in the century, or like James Lovelock and Richard Dawkins in the early 2000s. A scientist who transcended science and became a cultural icon. By the end of his working life, Einstein's written output was enormous. Nearly 300 academic papers over 55 years. That's how scientists in the hard sciences communicate research, through papers in journals, not books. He did write some books, over a dozen, but those were mostly compilations of his existing work, reorganized to make them more accessible or to use as textbooks. They were translated into multiple languages, making his work accessible around the world. Beyond his academic work, Einstein was a prolific letter writer. The Albert Einstein Archives at the Hebrew University of Jerusalem has over 3,500 pages of his private correspondence from 1912 to 1955. He also wrote extensively on political, philosophical, religious, and humanitarian issues. Collected editions of his work, like those published by Princeton University Press since the late 1980s, stretch into dozens of thick volumes. And despite all this brilliance and fame, Einstein remained remarkably modest. He once said, "I have no special talents, I am only passionately curious." He never acquired the trappings of wealth. Visitors to his homes, whether in Berlin in the 1920s or America after 1933, were always struck by how modest they were. The most lavish thing in his house was usually a piano, so he could play the classical music he loved. His family life, though, that was complicated, it has to be said. His two biological sons went to live with their mother Malva after the separation in 1914. After that, their relationship was distant. Hans eventually immigrated to the United States in 1938, and he and Albert reconnected, but Eduard stayed in Europe. Despite maintaining a correspondence with his father, he never saw Albert again after he left for America in the early 1930s. Eduard developed psychiatric problems later in life and was institutionalized in Zurich. That must have been painful for Einstein, being so far away and unable to help his son. Albert's marriage to Elsa was strained too, long before her death in New Jersey in 1936. It's been widely speculated that Einstein retreated into his scientific work at times as a way to avoid dealing with his own emotional weaknesses. His relationships with people were complicated. He was better at understanding the universe than understanding human hearts, maybe. Politically, Einstein was deeply humane. He held a lifelong aversion to violence and war. He deeply admired Mahatma Gandhi and his non-violent resistance to British rule in India. The two became correspondents, exchanging letters about peace and justice. Over time, Einstein's political views moved towards socialism. He was critical of capitalism. He wrote about wanting a system of global government, an end to competition between nation-states. He thought humanity needed to move beyond nationalism if we were going to survive. He had positive views of the United States. He saw it as a meritocracy, a place where talent could rise regardless of background, but the FBI kept a file on him. Before he even fully relocated to America, they were watching him. By the mid-1950s, that file was over 1,400 pages long. Not entirely unusual for a former German immigrant and an intellectual in post-war America, but still kind of unsettling. An intrinsic part of Einstein's character was his Jewish heritage, though he himself was an agnostic. He saw the Bible as a collection of what he called primitive legends. He didn't practice religion in a traditional sense, but his Jewish identity shaped his life profoundly, especially from the 1930s onward when it forced him to flee Nazi Germany. Einstein became known in his later years for supporting Zionism and the State of Israel. He'd visited Palestine back in the 1920s, when it was under British control after World War I. Hundreds of thousands of Jews were already living there or migrating there, trying to rebuild a Jewish homeland after nearly 2,000 years of diaspora. In 1925, Einstein agreed to be listed among the first board of governors of the Hebrew University of Jerusalem when it was established. That was a significant gesture of support. Then after World War II, hundreds of thousands of European Jews who'd survived the Holocaust headed for the Holy Land. When the British Mandate expired in March 1948, the Jewish people declared the new state of Israel. In 1952, Einstein was offered the ceremonial position of President of Israel. He declined, citing his age and his inability to leave the United States at that point in his life, but he remained supportive of the Zionist movement until his death. You have to wonder, though, what the pacifist in Einstein would have thought about the endless wars that followed, the Israeli-Arab conflicts, the Suez Crisis of 1956, the decades of violence that continue to this day. Would he have maintained his support? We'll never know. By 1956, when the Suez Crisis happened, Einstein was already gone. Shortly after the end of World War II, he'd begun suffering from an abdominal aortic aneurysm. That's an enlargement of the abdominal aorta, the largest artery in your abdomen. It can become blocked due to high blood pressure, high cholesterol, smoking. Einstein had the problem operated on successfully in 1948. They reinforced the Jota Wall. He tried to improve his lifestyle after that. He even adopted a vegetarian diet, which was pretty unusual back then. But the problem came back. Early in 1955, the Jota ruptured, internal bleeding. He was admitted to the hospital on April 17th. The doctors wanted to do emergency surgery to try to stop the bleeding. Einstein refused. He said it was best to meet death with dignity when your time had come. That's very much in character for him, you know, philosophical about it, accepting. He died the next day, April 18, 1955. He was 76 years old. Here's something kind of disturbing. The surgeon who did his autopsy removed Einstein's brain for scientific study, without the family's permission. It was dissected, studied. Today, the remains are in the National Museum of Health and Medicine in Washington, D.C. Some sections were put on display in the Mutter Museum in Philadelphia in 2013. Scientists have suggested that the abnormal number of glial cells in his brain might account for his extraordinary mathematical ability. Maybe, or maybe genius is more mysterious than that. His body was cremated shortly after his death in New Jersey. His ashes were scattered at an undisclosed location, modest to the end. So what do we make of Albert Einstein? He was one of the most influential thinkers in the history of science. His surname has literally become synonymous with genius. If you call someone an Einstein, everyone knows what you mean. What's most remarkable is where he came from. In the 1890s, he was basically an international nomad, a teenager moving between Germany, Italy, and Switzerland, as his parents tried to balance their finances with supporting their brilliant son. The Polytechnic School in Zurich gave him some stability, but when he graduated, universities didn't want to hire him. So he spent years working in a patent office in Bern, evaluating inventions during the day, starting a family, and at night, working on some of the most significant physics research ever undertaken. And then came 1905, the miracle year, 4 groundbreaking papers that revolutionized our understanding of the universe: photons, atoms, special relativity, mass-energy equivalence, 4 papers that changed everything. After that, Einstein rose through the academic ranks year by year. University of Bern, University of Zurich, Prague, back to Zurich, and finally Berlin, the peak of European academia, just as World War I broke out. During that catastrophic war, he developed general relativity. In 1921, he won the Nobel Prize. But what's most notable from the 1920s onward is his public profile. He traveled the world: the United States, South America, Europe, the Middle East. He used his fame to advocate for causes he believed in. The most significant was sounding the alarm about Nazi Germany from 1933 onward. He immediately renounced his citizenship when Hitler seized power and moved to the United States. He warned about the danger of the Nazis acquiring nuclear weapons. But that came with a terrible cost, because to defeat the Nazis in the nuclear race, the US developed its own atomic bombs, and then dropped them on Hiroshima and Nagasaki in 1945. Einstein, the pacifist, was devastated. After the war, he advocated for a Jewish state in the Middle East, a homeland for his people after the Holocaust. When he died in 1955, he was the most acclaimed scientist in the world. He influenced entire fields: physics, mathematics, cosmology. The history of the 20th century might have been fundamentally different without him. The technology we use every day, from GPS to automatic doors to nuclear power, all traces back to his work. But beyond the equations and the discoveries, Einstein represented something else: curiosity, humility, the willingness to question everything, even ideas that had been accepted for centuries, the courage to be wrong and admit it, the ability to see beauty in the universe's complexity. He once said he had no special talents, just passionate curiosity. Maybe that's the real lesson, that genius isn't about being born different. It's about never stopping asking why, never accepting that we understand everything, always looking deeper, questioning more, wondering what else might be true. Einstein showed us that the universe is stranger and more beautiful than we ever imagined, that time and space are flexible, that mass and energy are the same thing, that gravity isn't a force pulling us down but the curve of space-time itself, that light is both a wave and a particle, that atoms exist and we can measure them. He took reality apart and showed us what it's really made of. And in doing so, he gave us the tools to build our modern world. So what do you think? Was Einstein the most revolutionary intellectual in modern history? What explains his extraordinary intellect? Was it the unusual structure of his brain, his education, the unique circumstances of his life, or something else entirely, something we still don't understand about genius? Think about it, a patent clerk who couldn't get a teaching job, working at night after putting his kids to bed, changed how we understand literally everything. If that's not inspiring, I don't know what is. That's the story of Albert Einstein, from humble beginnings in Ulm to changing the world from a desk in Bern, from being stateless and unwanted to becoming the most famous scientist who ever lived, from writing 4 papers in one miraculous year to spending 50 years pushing the boundaries of human knowledge. His life reminds us that genius can come from anywhere, that curiosity matters more than credentials, that asking the right questions is more important than having all the answers, and that one person, with enough passion and dedication, really can change the world. Thanks for listening to this journey through the life of one of history's greatest minds. Einstein's story is our story too, the story of humanity reaching for understanding, no matter how strange or difficult that understanding might be. The story of never giving up on the pursuit of truth, even when that truth turns our entire worldview upside down. And maybe, just maybe, his story will inspire someone listening right now to ask their own questions, to pursue their own curiosities, to make their own discoveries. Because that's what Einstein would have wanted. Not to be worshipped as a genius, but to inspire others to be curious, to wonder, to discover. The universe is still full of mysteries. Einstein solved some of them, but countless more remain. Who knows, maybe you'll be the one to solve the next one.